lecture we will talk about symbols and valency. As you can see in this periodic table that different elements are shown. Each element is represented by a symbol. Symbol is the representation of an element. We can say that symbols are the abbreviations for the name of element. A symbol is taken from the name of that element in English, Greek or German. As the first element is hydrogen, it is not shown with its full name, just a representation of H. If one letter symbol, for example in the case of hydrogen, there is only a one letter symbol. You have to write this single letter in capital. Similarly, nitrogen is represented by single letter symbol, which is nitrogen. Yes, you have to write in capital. Similarly, for carbon representation or abbreviation is capital C. Now, coming toward two letter symbols. For example, in case of calcium is represented with a symbol Ca. The first letter is in capital, however the second letter is in small. Now coming towards sodium is represented with Na. First letter is capital and the other one is small. Now, as sodium gets its name from the English word soda. Sir Humphrey Davy used caustic soda when isolating the elements. The symbol Na comes from Latin word natrium. Latin word natrium. Yes, this Na, this. Because natrium was used as soda, so it's get its name sodium. Now let's start valency. Valency is a combining capacity of an element with another element. Let's first talk about covalent compound valency. First of all, we will talk about simple element, which is hydrogen. The combining capacity of hydrogen is 1, as it is shown that each hydrogen is singly bonded with one hydrogen. For fluorine, this element is fluorine. Yes, symbol capital F. Now its combining capacity. What's its combining capacity? Fluorine is combined with one hydrogen, so the combining capacity of fluorine is 1. Similarly, the combining capacity of hydrogen is also 1. Chlorine, this is represented with two letters. The first one is capital and the other is small. Yes, don't write symbol or abbreviation of chlorine like this. This is the wrong abbreviation. You have to write first letter in capital and the other one the second letter in small. Now, what's its combining capacity? The chlorine combining capacity is also 1, as shown that each chlorine is combined with one hydrogen. Now, let's talk about bromine. The abbreviation of bromine is Br. The first letter is capital and the other is small. The combining capacity of bromine is 1, as it is bonded with one hydrogen. I must define here that what is the covalent compound's valency. Covalent compound valency is the number of hydrogen atoms which combine with one atom of that element, or the number of bonds formed by one atom of that element. Example in the following compounds. Now let's again do some practice. We are now talking about oxygen. Yes, you must guess what its combining capacity. The combining capacity of oxygen is 2. How we judge that? Because oxygen is combined with 2 hydrogens. Coming towards nitrogen, nitrogen is represented with capital N, and the combining capacity of nitrogen is 3. Why so? Because each nitrogen is combined with 3 hydrogens. The last example, the last one is methane. You can see that in methane there are each carbon is surrounded or bonded with 4 hydrogen. So what will be the combining capacity of carbon? Yes, exactly, the combining capacity of carbon is 4, nitrogen 3, oxygen 2, fluorine 1, chlorine 1, bromine 1, and yes, for hydrogen it's also 1. So that's all for covalent compound valency. Now let's start ionic compounds valency. In simple ionic compound, valency is the number of electron gained, either gained or lost by an element to complete its octet. Now, first of all, I must introduce the term duplet. Duplet is the, we talk about duplet when there is only one shell, not more than one shell. So, for example, hydrogen and helium. In hydrogen, there is only one shell and only one electron accommodate that shell. However, in helium, there are 2 electrons residing in its shell. Helium is stable because we are talking about duplet. In duplet, only 2 electrons are required for the stability. Helium is stable because it already have that 2 electrons. However, hydrogen is not stable because it only have 1 electron. So it want to be stable and it gain that stability by gaining 1 electron. So we already talked about it. The combining capacity of hydrogen is 1 because it have to receive that electron. Now, what's octet? Yes, as the term shows that octet is 8 electrons. The next stability level is to gain 8 electrons. When we talk about 8 electron system, yes, when there are more than one shell, you can see that in sodium, yes, sodium Na, why not Sa? Because sodium get its abbreviation from the Latin word which is natrium, as I said earlier, not and sodium is its English version. Yes, because that element was used for isolating and was a soda, so its English name is sodium, and however its Latin abbreviation Na is gained from the word latium. Yes, for sodium there are 3 shells, 1, 2 and the third one. Now for such type of system, 8 electrons is the compulsory rule. The element have to get stability by 8 electron system. Sodium, as the innermost is 2 electron, doublet is complete. The next one is accommodated by 8 electron and the outermost only have 1 electron. So it have to gain 7. By gaining 7 it will become 8, or either it will lose that single electron to gain its stability. So it's very easy to lose 1 electron. So sodium will lose that electron as represented here with that arrow, that it will lose that electron. Now if we talk about chlorine, yes, chlorine, its abbreviation is Cl, the first letter is in capital and the other one is in small. You can see that in chlorine there are also 3 shell. The first one is accommodated by 2 and it completes its duplet rule. In duplet, the first shell have to accommodate 2 electron. In the next level there is 8 electron, and if you count in the last shell that the number of electrons are 7. 1 2 3 4 5 6 7. Yes, I am talking about the outermost. Valence mean outermost shell. We will not talk about its inner system, only its outer one. Now it have to gain 1 electron, so sodium will donate that electron, okay, as represented here, that the X for sodium, it is donated, it is given or lost, and chlorine is receiving that electron. Now both are stable. How? Now let's talk about its outermost shell. 1 2 3 4 5 6 7 8. And for chlorine 1 2 3 4 5 6 7, and this cross one is 8. So both are stable by attaining octet, and octet is 8 electron in the outermost shell. Element prefer to lose electron. Which are the element which prefer to lose electron to get its stability? Sodium, magnesium, aluminium. Okay, as you can see that the innermost accommodate 2 electron, its duplet is complete. Now the next level is of 8 electron. Yes, there are 8, and the outermost only 1 electron. So we only talk about the outermost. We have no concern with the inner one, only the outermost or the valence electron. So it have only 1 electron, and it must have 8 electron to get its stability. So it have to receive 7 electron, but it's very difficult to receive 7 electron, so it prefer to lose this single electron. Yes, it will lose this electron, and it will become 2 in the inner, and 1 2 1 2 3 4 5 6 7 8, and the 8 in the outer, and the outermost is finished. Now if we talk about magnesium, yes, inner 2 then 8, and the outermost only have 2 electron. Now how many electron it needs? It need 6 electron. 6 plus 2, it will become 8. So it's very difficult to get 6 electron. So what will happen? It will prefer to lose these 2 electron. Exactly, ये भी ले लो, जान छोड़ दो, to get its stability. Now let's talk about aluminium. Aluminium, as you can see that outermost, yes, we are talking about the outermost, it have 3 electron. To complete its octet, 3 plus 5 is equal to 8. It already have 3. It have to receive 5 to become 8. So it's again very difficult to gain 5 electron, and it's easy to lose 3 electron. So it will lose 3 electrons by losing this. This shell will vanish, the outermost shell will vanish, and which will come out this 8 electron system. So sodium, magnesium, and aluminium prefer to lose electron. Okay, which are the elements which prefer to gain electron? Now if you talk about nitrogen in the outermost, 1 2 3 4 5 electrons are in the outermost. How many are needed? to become 8? Yes, 3. So it's easy to gain 3 electron. So it will prefer to gain electron. Now oxygen, how many electrons at its outermost? 2, 3, 4, 5, 6. 6 electron. How many it have to receive? 2 to become 8. Yes, again it's easy to receive 2 electron, and it's difficult to donate 6 electron. It's very difficult, so it will gain 2 electron. And the last one is chlorine. Chlorine, at you can see at its outermost there are 7 electrons. 1, 2, 3, 4, 5, 6, 7. 7. Okay, how many it have to gain to become 8? Yes, exactly 1 electron. It need only 1 electron to become 8. So it's easy to gain 1, and it's very difficult to lose 7. Okay, this is again easy version. You can see that group 1 prefer to lose electron. How many electron? 1. Group 1 loses 1 electron. Group 2 loses 2 electron. 3. Group 3 loses 3. 4 can either take 4 electron or will lose 4 electron. And this group 5, in group 5 it's difficult to donate 5, and it's easy to gain 3 electron. The 7 in 6 group, it's difficult to donate 6, and it's easy to gain 2. The minus sign represent gaining of electron, and the plus sign represent losing of electron. And the last group is noble, which is stable, which already had completed their octet and doublet. Okay, now let's start radical. A radical is group of atom that have some charge. Radical with valency 1, valency 2 and valency 3. Okay, ammonium as shown have valency 1, hydroxide 1, nitrate 1. If we talk about valency 2, carbonate, sulfate, sulfide, they have valency 2, means they can combine with 2. For example, if we talk about sulfate, H2SO4, means you can see that its valency is 2, and 2 hydrogen are adding. And now the last phosphate, you can see that valency of phosphate is 3. With how many hydrogen it can combine? Yes, exactly 3. 3 hydrogen it require to become sulfate, hydrogen sulfate. At the last we have iron, Fe. Now you must say that iron symbol contradict its name, but not. Actually, iron get the symbol of iron, Fe, gets its symbol from the Greek word ferrum. Ferrum, FERRUM, ferrum. So some elements show more than one valency. They have variable valency. For example, in ferrous sulfate, the valency of iron is 2. Iron sometime or ferrum sometime show +2 valency. Its combining capacity is 2, and sometime its combining capacity is 3. So such elements show variable oxidation, variable valency. You have to learn that the +3 valence, the first 3 +3 is for ferric and +2 is for ferrous. So that's all for today. Okay, do share your thoughts in the comment section below. I love to hear from you. Thank you.